Welcome everyone to this month's edition of the ReproNim webinar series. Today we have Jeff talking about drowning in data and how to learn to swim in ReproNim's data ponds and lakes. And it's the TRD1 data discovery turn to give us some presentation. I'll just foreshadow that next month's will probably be something about training, but stay tuned through our communication channels to hear more about what will be next month's presentation. So without further ado, the floor is yours, Jeff.
Oh, thank you. Yeah, this is one in a series of presentations, as Dave mentioned, from TRD1. In the past webinars, we've introduced some tools, including IDM, that was the last one that Dave Keeter provided. And now what we're starting to do is sort of integrate a lot of those tools into sort of our concepts of data ponds and lakes. And so this presentation is sort of the introduction to the data ponds and lakes, and actually brings together a bunch of tools, shows you sort of how ReproNim's tools can help you in your local lab, but can also provide access to larger amounts of data. And it also provides, the necessary introduction to some of the concepts needed to navigate the data ponds and lakes, namely RDF and Sparkle. So that's sort of a brief overview of the presentation. And within ReproNim, there are a number of sort of helpful resources. So one of them is the 5 steps to more reproducible neuroimaging research. And the important pieces here, really start at the data collection side of things. When we're talking about the ponds and the lakes, in terms of data, being able to use data, we start thinking of structured data formats. And especially, with the, neuroimaging workflow, you're capturing a lot of different types of data, from the acquisition data to data that's been processed and aligned, to the various analyses and workflows, that are run on that to generate derived data. So there's, lots of different types of data that one is collecting on, your local file systems, for example. And then when that needs to be published, there's a lot of data to annotate to actually get that in an appropriate repository. And one of the key sort of founding principles, with all the work that we do in terms of, providing data resources, is the concept of FAIR. So whenever, we're looking to make data, more reproducible, key aspects of that are driven by FAIR principles in terms of, ensuring that, the ways that we sort of annotate the data, the way that the data is laid out, that it's interoperable, that it's reusable, that you can actually find information that you want to use. And, on, in local systems, in your own lab, findability actually might be an issue, in terms of, what tools do you have to actually, do queries across all your data. And then accessibility, in terms of, what repositories it's in, how can you get access to that data, how can you get access to that metadata. And so again, I'll be touching on a number of these principles as I go through this presentation. So first, the introduction to data lakes. So data lakes, are really, single stores of data that include many different types of data sort of brought together. So the data can include, any type of structural data. Structured data can include semi-structured data. And basically, this concept of a lake is that, we're putting all this information together in a place that it can be used and worked upon. So example is, in your, local lab setting, if you're collecting, your MR data on your local file system, you actually, for example, you're using, BIDS format for that. You have a number of, structured data, in terms of, the raw data, the actual imaging data. You have a number of structured data, in terms of what the bids format prescribes in terms of describing that data. And you might have, some unstructured data that you have in there, your lab notes or, images that are derived from that data. So, that type of data collection, is something that needs to be, well documented and specified so that, you can actually go in and take a look at, what's happening with your data. So the concept within ReproNim around these data lakes is that you have, for example, on your your local site, you're collecting data from a scanner. As I mentioned, it might go through a number of analysis workflows, generate more data, and this is then what ends up, in what we're calling a ReproPond. Okay, so this is a local data store that includes, files, the DICOM files, Nifty files, bids bids files that are associated with that. Any results, for example, if you're running FreeSurfer, that results in a bunch of, derived data results. This ReproPond contains all this data, and that, in a sense, can also be private to you. Okay, so, that doesn't need to be shared. But once you publish your data, that can be, a public repository, or as within ReproNim, it can be a collection of information from these repositories, to provide a place to sort of query the metadata, the results data, to find that type of information across these different resources. And when we look at the overall sort of ReproNim infrastructure, it's really, it's not a single monolithic application, but it's a suite of tools that really is meant to assist the researcher locally, but then also provide some centralized resources for utilizing the data within the global ReproLake. And so, for example, locally, there are things such as Blaze Graph, which an IDM works with, and again, I'll talk a little bit more about that down the road. And then, for the ReproLake, what we're using right now is GraphDB, but there are, potentially other solutions that we might move forward with as well. So, starting with your local collection of data, and so basically your own ReproPond. We all know that there are a number of motivations for structured data, and again, this comes from the bids documentation. But basically, many of the experiments are complicated. You can organize them in many different ways. There are many different files, per subject. Members of the same lab may use different ways to arrange data. So again, creating sort of this structured data format is very important. To have a way to consistently be able to access and what I'll be showing as well, how to query this data. And so within ReproNim, that all starts with the first level of normalization using bids. And so that's sort of the file level, folder level type structure, that makes it easy to cross many different studies. And so within ReproNim, one of the Repro tools is ReproIn, and this is really to help you collect and prepare your imaging data in an efficient and automated way, and basically convert your data as it comes in into bids. And so again, this is a tool being developed by TRD3, and it uses HooDiConf, which is a DICOM converter sort of in the back end. And a number of different workflows have been developed in different brain imaging centers, in terms of doing this type of conversion. And so again, from the get-go, creating sort of a structured format. Now the question is, how do I actually provide additional information about that data? So BIDS has, the data files in a nice structure, but there isn't a sort of, singular data source representation, data representation about that. And so that's where the neuroimaging data model comes in. And so an IDM is a set of specifications that really provide the ability to use provenance information to link all the components, within your data sets together, from, the experimental parameters all the way to results data. So linking, subjects, for example, that have had T1 scans, to their FreeSurfer results, that exist in some other folder, but having it in a consistent format that is actually queryable. And there are 3 specific specifications. There's an IDM experiment, there's a workflow specification, and the results specification. And this is all built on Semantic Web and provenance specifications. And I'll introduce those concepts as well. In terms of BIDS and IDM, they are very synergistic, and they work well together. An IDME, doesn't provide any representation of the data on the file system. The BIDS has the metadata stored in the human readable JSON and TSV file format, so it makes it very easy when you're going in to the file system to see, what your imaging experiments are describing, whereas an IDME provides, the specifications for constructing, unambiguous metadata descriptions that are stored, internally as graphs. And again, I'll cover that a bit later. And it's agnostic to the data format and is queryable, has query support through some of these semantic web tools. And so, these two work really well together. And as I mentioned, an IDM is based on RDF. And so, the semantic web is a concept that's been around for quite a while. So Tim Berners-Lee, had some quotes regarding what his vision was, that his dream of the web, where computers could would be capable of analyzing all the data on the web, based on the fact that the information on the web would be appropriately annotated and marked up. And semantic web really is trying to develop tools to make sure that information is understandable by computers, so computers can perform more of the tedious work. Again, if you have your data sets on your local file systems, adding these layers on top of that data using some of the tools we're developing then allows the computer, in a sense, to be able to pull that information together and provide ways for you to query it and use it. This is also sometimes called linked data. So if you hear about someone talking about linked data, that also is sort of the semantic web RDF concept. And really, it all resolves around the idea that you're describing data with, what actually sometimes looks like a URL, right? So that, anything that's described in a document, so let's say a FreeSurfer result, and you'll see this later on as well, a FreeSurfer result for a specific brain region is documented as being, the hippocampus through the use of a specific URL, and then you can actually go to that URL and find out more about that structure, for example. Oops. Okay, so the way that data in this semantic web linked data world is described is through the resource description framework. This is actually a World Wide Web specification, and it was originally designed as a metadata model, but it is, basically has come to be used as a very general method for describing or modeling any type of information. And so basically, in terms of how it sort of fits in the entire sort of stack of, W3C specifications, there's, RDF as a data exchange format, then you have, on top of that, you have ontologies. So this is definitions of, for example, particular terms or entities that might be described in RDF. You have, Sparkle, which is the querying aspect of that, and then you have higher levels of, logic and inference that can be applied. This has been around for a while, and is really now a way to to represent this information. If you want to find out more about the specification, you can go to the W3C, and they have the RDF spec online for you there. And basically, RDF, the data model itself is very simplistic in that it's basically a syntax that revolves around what's called a triple. So basically, you have a subject, a predicate, and object, and that is, what is, used to define your data. And so, for example, here, this is an example from an IDM file. You have in this case, it's an acquisition scan. And the NIRI is an internal identifier of that scan within the IDM document. And then that has an acquisition modality. So this is the predicate, and the acquisition modality is magnetic resonance imaging. So if you look at an IDM file, you will see all these types of triples. And the important thing to note as well is that there's a shorthand way of defining sort of the URI. So this is a URL looking type identifier. And if you look at the URI for example, magnetic resonance imaging, this IDM is actually what is used to help expand. So this is actually, a shortcut representation, normally called a query, where IDM colon magnetic resonance imaging actually expands to the following full URI. If we actually look at the types of data in RDF, is that the vocabularies that we use to define and describe things, that's really the sets of terms that, for example, in IDM we have to define. So within IDM, there's a whole vocabulary of terms that we use to describe, that the imaging data and, for example, the results data. So, within the IDM specification, there's a whole defined vocabulary. And these terms are either classes or or properties, and there are different types of properties. So you have, for example, what's called an object type property, which is a relationship, which I showed you on the prior slide, which says that some term, so this acquisition scan, some object, has a relationship, to a certain imaging modality, right? And that imaging modality is, in the prior example, magnetic resonance imaging. So again, it's all building around this idea of triples. And you can also have other types of properties, so data type properties or attributes or annotations, where you actually specify an actual value, to something. So you could say that the volume in a certain measurement, right? So the volume, has has a measure of 40 cubic millimeters. So in terms of just some other sort of definitions, again, the classes that we deal with, the acquisition scans, the subjects, represent the things, in the real world or in the information world that we're trying to capture. There are relationships, between classes, for example, so links between classes. So you have a FreeSurfer measurement and the anatomical region it is about. And there are the properties, the actual characteristics, of, for example, the measurement. Within IDM experiment, it has a very sort of logical layout of what this graph looks like. So you have projects, you have sessions that are part of a project. You have an acquisition activity, and so, for example, the acquisition activity is linked to the MRI scanner, and that has a subset of scanner attributes, and the acquisition entity, that is the scan itself, has has a bunch of information, for example, the file name and a bunch of other attributes, and things like project also have attributes as well. So for a project, you might have title, the description, things like that. So again, it's logically laid out. And if you look at this in RDF, so this is a specific format of RDF, but what we're looking at here is that in the beginning you have usually a number of prefix statements. So these prefix statements, again, are the ways that one expands. Expands any URI that is in its query or short form. And then you have, for example, here you have an acquisition object, right? And so here we can see that there are a number of attributes. So the acquisition matrix, the echo time, the flip angle, the field strength. And again, here, the IDM, for example, the slice timing, again, this is what gets expanded to the full URI, it has all that information. So when one looks at the RDF representation, of these IDM documents, it's a very well structured, linked graph of all these entities and, the values. And these values have been extracted, from the backend bids files, and also additional annotation that you as a user might do. So if one looks at the IDM RDF graph, this then builds out, in terms of the number of sessions, the number of image acquisitions, that have occurred. And there's also, the collection of the assessment acquisitions. So, demographics that have been collected on subjects, that, as part of these sessions. And this imaging data can then also be related to results data. So for example, if one does an analysis via FreeSurfer, there are a number of volume computations that have been derived from these images, right? So this information about the volume computations is linked to the images, and then those volumes are described by, what they are actually measures of. And again, these measurements, so for example, brain gray matter volume, is defined, in a terminology, as is amygdala, so that there's additional information you can actually link out to from these results. So there are a lot of tools in terms of IDM, and Dave Keeter did the prior TRD1 presentation 3 months ago or 2 months ago. But that's available on the ReproNim website. So if you want a very detailed sort of run through of all the IDM tools that are available to you, you can go back to that presentation. But what I'm going to do is just down the line is give some sort of brief highlights. One of the key things that I wanted to mention is reusing vocabulary. So I mentioned that, if you have information that's tied to, for example, a brain structure, and you have an identifier for that brain structure, utilizing, the same identifier within the context of, you know, a collection of data sets becomes very useful, because then all that information ties together to those same external data points. And so it basically provides a way for alignment, but also adds to the interoperability of your data, and also allows others to tie into that same information. So in terms of, how do you get your data, how do you actually get a ReproPond, on your local system? Again, this is going to be done via PineIDM. So PineIDM is a Python library to manipulate the IDM data model. And there, a number of tools, for example, bids conversion to IDM. PineIDM has a full set of documentation online. So if you go to the GitHub and go to their docs, you'll have a full set of documentation to help you and help you work through using some of these commands. However, in ReproNim, what we've done is we've actually taken some of these use cases and developed sort of how-to description. So there are a number of different volumes in the How Would ReproNim Do This series. And what I'm going to be focusing on is this volume 4, How Would ReproNim Manage Local FreeSurfer Results, because this gives, it's an online tutorial that allows you to work through this on your own. I'll give an overview of that, sort of how that is used to create your own local ReproPond. And so, how would ReproNim do that in terms of this FreeSurfer example? Is we look at, generating encoded FreeSurfer results, and then querying those data sources. There are a number of steps in this process. The first step in this tutorial is actually generating. So if you do have, a collection of data in the bids and IDM format, you can then run this aseg stats to IDM. In this tutorial, we're running this on a single subject. And what that does is that it actually creates, you have your FreeSurfer data, you have your imaging data, and the aseg stats to IDM takes the resultant FreeSurfer data and converts it into an IDM representation of the volumetric measurements. Oops. And so again, this aseg stats files, it uses the APARC and aseg stats files and encodes them as an IDM. And there are also tools for FSL and ANTS. The actual tutorial only goes through the FreeSurfer. And the second step is then, well, how do I get information about the participants? And so within your bids data structure, you have participants.json or .tsv files, and potentially other data in the phenotype directory. And so somehow this has to be converted into a local representation that can be queried against. And so again, in this How Would ReproNim Do That series, in the FreeSurfer example, step 7 is adding the demographics. And this uses the PineIDM tool CSV to IDM. And that basically allows you to create, again, an IDM representation, this graph representation of the subject phenotype information. So the CSV to IDM goes through, basically creates a local data dictionary and associations between what's in the participants.tsv file, and then exports that as an IDM to your system. And again, it's a process that goes through a number of different steps, to walk you through sort of the creation of the NIDM files. The overall environment for this is that the NIDM annotation tools actually work with a number of other services, including a terminology service that I think the webinar on ontologies and interlects was in February, I believe, if you want to go back and take a look at that. So it links into terminologies to help align some of the data and export then the NIDM data to the local file system. So once you have the NIDM data there, you now need to be able to query it, and this is where Sparkle comes in. And so Sparkle is the RDF query language, and it basically can query any of data that's stored in RDF format. It is a standard, again, by the World Wide Web Consortium, and there are a number of other sort of large-scale projects that are using RDF as sort of back-end data to be queried. And so one that you might be familiar with is Wikidata. So Wikidata is a free and open knowledge base that is derived out of projects such as Wikipedia, Wiktionary, Wikisource, and also by contributions directly to Wikidata. So again, RDF is being used in a number of different places to provide these query interfaces. So when looking at the types of queries you can do, there are a number of different Sparkle queries. What we're going to focus on in this webinar is the basic select function, and that's basically returning a listing, or what you can imagine a table of results, satisfying a certain set of conditions. And when one looks at a Sparkle query, I don't know if anyone's done SQL, it looks a bit different, but it's pretty straightforward in terms of how these queries are constructed. So the first thing is that you need to define all the prefixes that are used. And so this is the exact query that is provided in the How Would ReproNim Do That tutorial, right? So we're defining the prefixes that are needed. So again, this is to properly expand all the URIs that are used. The type of query we're doing, again, is the select query. And what are we searching for? So here we're looking for, data related to a tool. So a tool like FreeSurfer, right? The label of the structure, the laterality of that structure, and the volume, right? And so the first part of, the next part of the query is really the patterns, that is the conditions that have to be met. And so again, since this is a graph type structure that we're querying over, right, we need to basically define, what we're actually pulling out, right? So, based on a activity, by a tool, right, that is resultant in some measures and volumes. We then need to further classify this measure. So this measure is a subclass of an IDM data element, right? So there are a number of different types of data elements that exist. And what we're looking for, right? So we're looking for these IDM data elements. And what we're trying to find is measurements that are, a certain measure of and a specific type of data. So what we're looking here, for example, this URL right here, if you were actually to put that in your browser, you would see that that is volume, is what we're trying to search on. And there are some other relationships that we're pulling out. So, the measure, this data element might have another relationship that says it is about a certain federated label, and that the measure has a certain type of a laterality. And what we want to filter this on, in this case, again, if you were to go to this URL, you would see that this is actually hippocampus, right? And so that's the basic structure of a Sparkle query. And you can then go in and use that for querying. Now, within IDM, there are a number of query methods. Some of them are a little simpler to use, and so there is a PineIDM query, which are parameter-based or REST-style API queries, and then there is the ability to use, for example, Blaze Graph and Sparkle, or just run Sparkle on local IDM files in your local system. And so parameter-based queries, again, if you go to the instructions, there are a number of different options in terms of what one can do with a PineIDM query. And what we're doing, what you see here, and this is again from the tutorial, we're doing a REST-like API. So here we're getting information about this project. And whoops, sorry, I always click my mouse when I do that. So PineIDM query, we're looking at this local file on the file system and running this this query, and we're pulling out all the information about the hippocampus. And you can then actually pull back all that data itself by, again, running through that that query and then specifying that you want to pull out certain fields, including age and this FS_003343. So again, that is an identifier in the graph, and that is the left hippocampus volume. Okay, so this is just using sort of the PineIDM parameter-based query, so you don't have to use the Sparkle. So what we're trying to do in ReproNim is provide certain functions, where you don't need to learn the Sparkle, right? So we can embed the Sparkle behind the Python tools itself. That makes it easier for users, to do common functions. But if you're really looking to do some very specific queries, you can then go into the Sparkle itself. And so to run, for example, the prior query that we went over, you can do that in a straightforward way with PineIDM, where you run a query. Again, you run it on a single TTL file. I mean, this could also be multiple TTL files. So the TTL in this case is called Turtle, and that's a specific RDF format. And so the IDM tools output RDF in this Turtle format. And you specify the query. Again, this query is a document. You specify what file that query exists in, and then you output that to a text file, and then you end up with a set of information like this that you can bring into any spreadsheet tool, and then work with the data that you have brought back. And again, you can imagine that you have, let's say you've done multiple studies looking at subjects, and on all your subjects you're running FreeSurfer. At some point you may want to go back and start looking at your hundreds of subjects worth of data with FreeSurfer, and start exploring that. And so this is a way if you're consistently documenting your data in this structured way using bids plus an IDM, you're able to go back at all your data, and pull out various aspects of it, and for further analysis, or for any type of tracking or reporting that you have to do. So now that we have, sort of this concept of a local ReproPond, now what happens, sort of, at the ReproLake. So again, at the beginning of the presentation, the ReproPond itself was your local metadata store, whereas the ReproLake is this global and public metadata store. And so within ReproNim, we've begun populating this ReproLake using data from a number of open studies such as Abide, ADHD 200, Core, and Open Neuro. And we're using this within a tool called GraphDB. And so, what this ReproLake is going to sort of become is what is commonly called sort of a knowledge graph, right? So we have the information that we're pulling in from all the studies, in those projects that I mentioned, pulling that into this global ReproLake. But then, we're also going to be adding information about, the structures and things like that, so that, you can do, various queries, on, the ReproLake, and, get sets of results, that link back. And so here you can see, that the ReproLake does not have the T1 weighted image itself. So we're not duplicating, the large imaging data within the ReproLake. What we're doing is aggregating the metadata and associated data, such as results and things like that, that we can query on. And the actual, for example, T1 weighted image remain with the source repositories. And so here, this Abide data links back to the T1 weighted image that exists in Amazon itself. And on the ReproLake, we have some sample queries that we're providing. And so here, what we're doing, and this is what was shown in the last slide, what we're showing is we're pulling out information on studies, subjects' age, their gender, some IQ measures, and the T1 weighted image. And here again, we are defining how what type of information we want, right? So we're looking for all the entities, right, that have this image contrast type of T1 weighted, right? So we're limiting our search to scans that are T1s, and then we're finding information about those scans in regards to their subjects. And so we're pulling out the age measure, right? So the age measure is a data element connected to that research subject, right? And this age measure is defined through the fact that the data element says that it is about age. So remember, this is all a graph structure. So we have a node that is a data element, right? That data element node says, I am about age, right? And that then has a value as another relationship in there, an annotation that contains the age itself. Same thing with sex. So again, we're forming these sort of graph-based comparisons, that we want to pull out. And then we say, for example, that this age measure, should be age. This sex measure actually gets coded. So there are a couple other things one can do in Sparkle. So, here is, an example of if you have different coding. So let's say, you had coded, male and female different in different data sets. What one can do is that, one can say that, if, the gender coded, the sex measure, as this gender coded property, if it's a 1, or male, right, that it should be set to male. And if it's neither of those, then it should be set to female, right? So, you can do some data alignment as well within Sparkle. And here, for example, the FIQ code, for example, has a numeric code for NAN. And so you can also do that type of binding as well. And so again, this shows you a little bit, in terms of, what you can do, with Sparkle. Again, there's, through GraphDB, there's a way to, provide these queries. You can go in, and then it gives you the output, and you can do an export of that. Again, this, the ReproLake is a very new aspect of ReproNim, and so there'll be more ways to interact with this in the future. So, for example, some of the PineIDM URL-based queries that one might do, you can envision in the future, as those libraries get updated, that we could potentially also do some of those actions against the ReproLake as well, using some of those simplified queries. And really, looking ahead, the idea is that it's not just going to be a sort of data extraction, data query type tool, but that we can really start layering on, as I mentioned, some of these external aspects, of defining, for example, brain structures using these URIs, is that we can suddenly start linking to, information from, anatomical ontologies about the hippocampus. And then also, because we have the data in the global ReproLake, we can then provide, for example, data overview. So really, providing a live, updated sort of knowledge source about, various concepts that might be defined, in the, in your graphs. And so, as I, had mentioned, this is going to be sort of the first set of these, as we sort of delve into, the ReproPonds and ReproLakes sort of in more detail. This was sort of the first presentation to sort of give the global overview and also give you some understanding of, what is used to build out these ReproPonds and ReproLakes. And again, I can't give a full tutorial on Sparkle. I mean, there are other places for information on that, and so I want to point you to additional resources as well. And so ReproNim does have some training material, and so there is a training module on data and FAIR principles, and this has further links and concepts around the web of data. And also semantic data representation. So this links to a number of external training resources that you can look at. And there are also a whole number of resources on IDM, including the repositories, the PineIDM itself. There's some IDM training materials, and then there's other associated repos. So again, lots of information, and I think I have finished within time, and also leaving a little bit of room for questions.
Thank you very much, Jeff. So yeah, we have time for some questions. You could chat them if you want, or we're a small enough group. Feel free to unmute yourself if you're allowed to. Let me check to see. You ought to be able to unmute yourself if you want to ask a question. And I'll seed the questions then, Jeff. So if you're a Python hacker or an RDF aficionado, I can sort of understand how one wades through all of this. Can you say a little bit more about how you expect the random end user in the end, after a while, to really be able to access this?
Yeah, so I mean, I think what we are trying to do, within ReproNim is sort of provide two sets of tools, right? They're sort of the tools for people who have, who are not the RDF hackers or Python hackers, but tools that one can run on the command line. So, the CSV to NIDM, the aseg stats to NIDM. And those are just sort of command line tools that, anyone who is using, any of the other sort of, command line imaging tools, should be able to run. And so, you don't see the back end sort of RDF and sparkleness of that. And it's the same thing with the sort of the high level PineIDM query tools I described. Those don't require, any knowledge of RDF structure or of Sparkle. All you need to know is that you have, projects which have, scans that are a part of them, and you can use then the various PineIDM, either parametric or those REST-based queries, where basically you say, okay, I'm interested in getting all the information about project X. And so PineIDM query, with /project/X will give you that information. So we're trying to develop, a set of more user-friendly tools. I mean, they're still command line based, so it's not, like an application where you point and click, but in the imaging realm, a lot of the tools are command line based, so people are sort of familiar with the command line. And if not, Yarrick has a tutorial and I believe a webinar on command line basics, so you can look at that as well within the ReproNim webinar series. And there's also a tutorial in the How Would ReproNim Do That, I believe, that gets into a little more detail on that. So again, I mean, we're trying to provide these more user-friendly tools, but also providing a bit of training also to get people more comfortable with using the command line.
Great. And I will point out that in the How Would ReproNim Deal With That FreeSurfer stuff, one of the cute examples is the crossover from your own local private, ReproPond data. But then, if you happen to be mucking with FreeSurfer at home, you can fairly easily suck in FreeSurfer from results from other public sources. And so it's really easy at home to sort of mix and match your local data with publicly available data. So in principle, that's kind of a cool way to work with that. Okay, I've monopolized the questions.
One of the advanced topics in one of our future webinars. So.
Excellent, good idea. I've monopolized the questioning. Anyone else out there from radio listening land want to venture a question?
This might be a little premature, but I'm wondering, if you are doing FreeSurfer on your local machine and you're pulling in FreeSurfer results from a ReproLake somewhere, like how do you envision getting past permissions issues and like authenticating with the NDA's database, for example?
Right. So what we're providing in the ReproLake is, again, it's not the imaging data itself; it's the metadata, and the resultant data. You can also be metadata. I mean, it's not binary data, and so we're bringing all that together. So within what we provide in terms of the ReproLake, there are no permissions issues there. If you have to go back to some of the raw imaging data, then you might potentially, with certain studies, you may run into issues with permissions there. So if you want to get back to the T1s and do something, but if you just want to look at, what did FreeSurfer extract as the volumetric measure of the hippocampus across all these subjects, you can extract that information. We're also collaborating with the COINS group, and so one of the things we're also looking at is how can we actually enable So now that we have the ability to query local collections of information, how can you do that across systems that do have issues with authentication and the like? And so one of our collaborative partners within the P41 is a group that's been working on coins, which is a distributed system, to allow people to use authentication to access data across sort of protected boundaries. And so, again, that's something we're working on. I mean, there's nothing that we have things running in our test environments on that, but nothing sort of that's publicly available yet. That's sort of something that's in development.
The extra nuance I'd put on that is things that require authentication is fine, and you individually get that. So you bring that content into your own ReproPond. It's not the public stuff. We're not redistributing things that can't be distributed, but we can give you ways to take your ABCD or your private HCP data or things you get from NDA, and yeah, you had to access it via your authentication, but then you can wrap it within your own pond and have access to it, in your pond, not via the lake, in the public sense. So it's going to be a mix and match between what you have authorization to deal with and what you don't need, and the public stuff, and trying to be able to seamlessly get back and forth between those.
Hey, Dave, can I add a quick thing to Petra's question? I think there also needs to be one more layer, which is getting access to information from the NDA. That's not just an access layer, it's also a technology layer. So there would need to be some translation from the information coming out of the NDA into the pond style or lake style representation so that you can search across.
Mm-hmm.
Okay, I think we've come to the end of our official hour. Thank you all for visiting. As you know, you can always find us online via the web, via the Twitter, via Mattermost and Slack. Next month will be some sort of update in the training space, exact topic to be determined. And thank you all for joining us. And thanks, Jeff.
Thank you.
No problem.